All right, people, let's do this. Moving on to 5-2. Um, Overall, this is going to be, I think, pretty easy, because I'm kind of doing a callback to concepts we've already sort of looked at. We're not really getting into anything super crazy new in this lesson, and you're going to be excited to find out that the only sort of painful algebra I'm kind of trimming, but you'll see. Here we go. Right away, yeah, you'll probably already notice that. The section is called Polynomials and Linear Factors. We're going to be factoring again. Your favorite. So standard form versus factored form. Again, we've already done this and talked about the relationship, but how we've already seen this in action. Told you. X squared plus 7x plus 10 is the same as these two bubbles being multiplied together. Because this would be, you could call it standard form, right? But this is when you have it factored. And so we call it factored form, which makes sense to call it that. Since these are the factors, this is like the factored version of x squared plus 7x plus 10. Now remember, how did we factor this? You know what I mean? We couldn't do a GCF, so we did unfoil. And this was an example of a pretty quick and easy unfoil. You can just make your bubbles right away because the two numbers, well, I guess first of all, because there's just really a 1 out in front of here. And then furthermore, the numbers that multiply to get positive 10, but they also add up to positive 7 would be this one and this one. It's a factor. Write the expression bubble times bubble times bubble as a polynomial in standard form. Well, skip. We're going to skip this, but I'll still show you in case you're curious. This is just some like ugly multiplying. It looks like I foiled those together, cleaned it up, and then you still have to do like even more distributing, and it just, I'm not going to worry about it. It's just basically reviewing the distributive property. So skip. This is not going to wind up on your homework assignment or test or anything. But just a quick recap, or maybe this is like a plot twist, some new twist for you. I don't know. But I think I covered examples like this. So if we wanted to factor this, don't forget, people, never forget this. What's the first method of factoring you should always try? Well, that would be by greatest common factor. And this trinomial, these three terms, have a GCF of 3x. You can divide 3x from all three of these terms. And when you do that, what's left over is x squared plus 2x minus 8. But the more I get into this, the more I remember, and the more sure I am that I did mention this at least once to somebody, if not everybody. After you bring out a GCF, you always need to check to see if the bubble factor can be factored again. Okay? And of course, this time you would have to factor it by unfoil. And it turns out that x squared plus 2x minus 8 does unfoil. So the 3x factor, the GCF factor, just comes on down, and this bubble sort of splits up into two smaller bubbles, So we did the GCF method, and then we did unfoil. Don't do them at the same time. And so this would be your final factored form. Okay? Another look at zeros. How we've already seen this in action. Well, remember when we sort of revisited 4-5 with the graphs? And we found out that if we wanted to find solutions to this, if we graphed this, see how like this one equals 0, but this one equals y? The graph of this, if you find the x-intercepts, it would be the solutions to that. But again, all the same stuff again. Find the zeros. Now again, I don't know if I said this. Look at zeros. Did I ever say this? I don't know, but in case I never said this, the zeros, quote unquote, right? That is like another word for like x-intercepts or solutions. Just think of it as the same thing, okay? Like there's some like nuance differences, I guess. It's all like in the terminology or the semantics, but just remember that when I say what are the zeros, I might as well be asking for the solutions or the x-intercepts. It's pretty much the same thing. So finding the zeros of this function, okay, it's the same as if you were to set it equal to 0 and solve it. Now, what I'm about to say to you next is very, 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 very important, and it's probably not even a surprise. But so this is very important, okay? When you're trying to find the zeros, or which like I said is the solutions, if your function is already factored, it's like Christmas. The fact that this is already factored was like a gift, okay? That was a very good thing. If it's already factored, you know the answers, because look, and this is like the biggest focus of this entire section, okay, 5-2. It's understanding the connection, if you didn't already from previous stuff, understanding the connection between the factors and the final answers, the relationship between the factors and the final answers. Because, and again, you probably already know this, if one of the bubbles is x plus 1, then you know one of your final answers is going to be -1. Look, bubble, answer, or 0. Bubble, 0. Bubble, solution. Okay? Same with this. If you know one of the bubble factors is x minus 2, then you know this is going to be one of your final answers after you set it equal to 0 and solve for x. So again, the leap between what the factor is and what the final answer is, or 0, it's not a big leap to make. And if one of your bubbles is x plus 3, then your 0 would be -3. And, we could graph this and whatever. But the connection here is hopefully pretty clear, especially from our past. How many zeros are there? Well, there's 3 of them. There's 3 different of these answers or zeros. What is the degree? Well, the degree, if you were to multiply it together, is 3, but I'm not even going to open up that can of worms right now. This is basically, I know it looks ugly and it's very textbook, kind of, textbooky, but this is what I just got done saying. If you know one of the factors, then you know the corresponding 0, and vice versa. If you know the 0 or the zeros, you can say what the factors are. It's a very easy leap to go back and forth between like the factor and the solution. So, like, if I tell you that a polynomial function has these 3 zeros, then you should like that. You should be able to tell me that, oh, if one of my final zeros or answers was 4, then my bubble factor must have been x minus 4. It's kind of like reverse engineering. And if one of your final answers was -1, then this must have been one of the bubbles, that you would set equal to 0 to get that, And look, the function in standard form, once again, this is the kind of just, I don't know what the word is, annoying or arduous, just such busy work, like multiplying all this stuff together. I'm not going to have you do that. The examples down here, I will have you do this because it's not as crazy as multiplying 3 bubbles together to get back to your standard form. So again, I know I'm kind of talking fast. You can always rewatch the video, but I want to make something clear, right? I'm not going to make you do on the homework and stuff where you got to take 3 bubbles and multiply them together to get back to standard form, because look, this would be your final standard form, whereas this was the factored form. I'm not going to make you multiply 3 bubbles together, but I think I'll have you do stuff like this where all you're doing is multiplying a couple things together. That's super quick and easy. So if my zeros in this example are 3, that's why you might not see these examples on your notes, so you just kind of write them in, okay? I think I just threw these examples in here on an audible, calling an audible. So anyway, this brand new example out of nowhere. What if 3 and -5 were my zeros? What would that make the factors? Huh? Wouldn't it be, x minus 3 times x minus 5? And by the way, technically, I'm not gonna write that. Oh, come on, man. No. What you should also include here, peoples, is a y equals, So don't forget that. Technically that's what you need, right? But anyway, if 3 is a 0, then x minus 3 is a bubble, and if -5 is a 0, then x minus -5, right? This is technically x minus -5, which is x plus 5. So I don't think it's too much to ask for you to go okay, now I want you to change this into standard form by foiling these bubbles together, distributing them together, multiplying them together. And after a step or two, you end up with x squared plus 2x minus 15 when you foil these bubbles together. This next example. Oh, and by the way, geez, that took a while. Y equals. So what if your zeros were 0 and 4? What would your factor be if your final 0 was 0? Would you write a bubble of x minus 0? Would you need to write x minus 0? No, just write x. Okay? Just write x. You could write x minus 0, but just writing x is the same thing, and so from this 0 you get a bubble of x minus 4. And again, if what I want is standard form, I don't think it's too much to ask. It's quick to just multiply this stuff together to get y equals x squared minus 4x. So that's not so bad. Again, I'm not going to make you go through the pain in the neck process of doing all of this multiplying together. Okay, so just examples like this, where you want it in standard form at the end. How many zeros? I'm going to try to fast track this because, look, people, when, up here, and you've seen this in the past, when you factor and you get the same bubble twice, You know, so like you factor it and you get a couple bubbles and you're like, okay, so x equals 4 or x equals 4? Why are you saying it twice, right? I mean, remember those situations where you'd get like x equals 3 or x equals 3. So there wasn't really two answers, there was only really one because it was like a repeat answer. We're going to start throwing around the word multiplicity when it comes to that. You know what I mean? So like when there's a repeat 0, when there's a repeated answer or a repeated factor, you just say like that particular 0 or that particular factor has like a multiplicity. Like if there was, so this one had like this 0 of x equals 4 had a multiplicity of 2 because it appeared twice. It's not rocket science. So let's do like a couple more examples to finish things up, okay? What are the directions here? The directions would be find all the zeros, basically. I don't know if that's like a technically perfect set of directions, but that's essentially what we're doing. We're taking these functions and we're going to find all of the zeros, okay, including whether there's a multiplicity or not. If there's a multiplicity, you know, if there's a repeat 0, we're just gonna state that. You know, we're just gonna say that. You know. But anyway, how do we find all the zeros, people? What do we have to do to find the zeros of this? Well, I mean, if this function happened to be already factored, we'd be in great shape. But it's not. And so, you know, alas, we're going to have to factor it ourselves. Oh well, we can do it. So what's the first method of factoring we always try, huh? GCF. Okay, and we're also going to be technically setting it equal to 0, you know, to get our zeros. So our GCF was x squared. So we factored it out, and what we were left with was this. And then again, you have to check this bubble again to see if you can now unfoil it and keep it going, like factor some more. Which it turns out, this bubble, now again, the x squared just comes on down. But what, you know, how do we factor this bubble? Wouldn't it just be like quick and easy unfoil? What two numbers multiply to get -8, but they also add up to -2? Right there. And so look, now that we know the factors, we have a factor of x squared, we have a factor of x minus 4, we have a factor of x plus 2. We could jump to the final zeros just like that. Technically, we're setting them all equal to 0, but I mean, look, was it a big shock that we ended up with, like, once you knew this was a bubble, I mean, one of our zeros is 4. And because this was a bubble, one of our final zeros was -2. And because we had a GCF of x squared, you know, technically we get a 0 of 0. Okay, so get used to this. Because I want to say, like, a quiz we took last week or something, some people were not understanding, like the same thing happens over here. You know, when you get a GCF of x, one of your final answers is going to be 0. Okay? So again, I know I brushed through this really quick, but there was a GCF here of x, and then after I brought that out, I noticed that this factor can be factored some more, you know, and it turned out that the two bubbles were both x minus 2, and so look, you would say like, so x minus 2 equals 0 or x minus 2 equals 0. You're getting the same answer twice. And so this is what I mean by saying, okay, so one of my zeros is x equals 2, but with a multiplicity of 2 because there was 2 of them. Okay? I mean, that's kind of, and again, here's the semantics I was talking about, people. X plus 3 is, but this is a pretty good summary, I guess. So x plus 3 is a factor of this. I mean, right? What would the other factor be, by the way? When you factor x squared plus 7x plus 12, what's the other factor? Wouldn't it be x plus 4? Anyway, that doesn't matter right now. So x plus 3 is a factor of this. Negative 3 is a what to this equation? Notice that it's equal to 0. Well, what could we call negative 3? I mean, again, since x plus 3 was a factor, negative 3 is a what to this equation? What do you think? I'm going to go with solution. Yay! But what about this? Negative 3 is in blank of the graph of this with the y equals and everything, not the equals 0, but the y equals. So negative 3 is a what? Of the graph of this. I'm going to go with x-intercept. Yeah, and still the champion. And then negative 3 is a blank of this function. It's like period. You know, this is where you would technically be able to say the word 0. But whatever. These are all so close together. You know, and as long as you understand the relationship between x plus 3 being a factor and negative 3 being like a 0 or a solution, I mean, you pretty much got the grip on this that I want you to have. You know what I mean? As well as like if you had a factor of 5x, okay? If a factor was 5x, then I hope you understand that 0, you know, x equals 0, would be a 0 or a solution. Now, hold on, don't go anywhere. Because what I want to do next is I want to kind of really quick run through the homework and kind of give you some pointers so you will be way less likely to get stuck. This won't take that long, and it'll definitely be to your benefit. So here's what your homework looks like. Write each polynomial in factored form. Yeah, you're just going to factor. Bring out a GCF, then look to unfoil, you know, whatever. But always start with a GCF if there is one, and there always will be one. You're welcome. There's always going to be a GCF first. Find the zeros of each function. Well, people, look at these 6 problems. They're already factored. All of these are already in factored form. You should be able to figure out these answers in like one step immediately because they're already factored. So again, if you know the factors, you know the zeros. Moving on. Write a polynomial function in standard form with these given zeros. Well, what you're going to have to do first is write the factored form, because if you know the zeros, you know the factors. Right? So first get the factors, and then you're going to have to multiply them together to wind up back in standard form. I hope that makes sense. And so again, like I said, these are not so bad. And like I'll leave this as optional, like that's why it's got the blue circle. I mean, because look, this might get a little nastier because there's like going to be 3 things to, 3 bubbles, spoiler alert, to multiply together. So don't do that if you don't want to. 24 looks like it's nasty, but because that 0 is literally 0, it's not going to be that nasty. Just do it. And then these other 2, once again, you can take them or leave them. I don't care. Whoa! Holy man, do we have a death wish? Look at this! 26, man. Bless your soul if you decide to do that. Actually, that looks like fun to me. And then 20, and then the last handful of them. Find the zeros of each function and state the multiplicity. People. What are there? 6 of these? No, 8 of these here. 2, 4, 6, 8. People. 6 out of these 8 are already factored. Okay? The only ones you have to factor yourself are 29 and 30, so make a note of that. 29 and 30 are the only ones you have to factor yourself. The other ones are already factored. And let me tell you something, just in case you're still a little confused about what you're looking at here and the whole multiplicity thing. When you see x plus 3 bubble, like this factor bubble to the third power, that just means there was 3 of them. So I'll tell you right now, the answer to 27 is x equals -3 with a multiplicity of 3, because there was 3 of those factors, which means that was like it got three-peated on that 0. Okay, so this should be not too bad, I hope.